So let's go to problem number 1 on the notes. And we've got a notation here, T, capital T, and then we see as a subscript the bracket notation. In fact, we've got bracket 7 comma negative 2. So this is the same vector that we just looked at on graph paper. So we're talking about a translation referring to this vector, saying that we're going to translate this object, the triangle ABC, 7 to the right, 7 in the positive direction on the x-axis, and then 2 down, or 2 in the negative direction on the y-axis. So this is the link between vectors and translations. Vectors describe completely a translation, because a translation, we said, was moving every point of a figure in the same distance and in the same direction, which means along the same vector. So here we've got notation telling us that we're going to take triangle ABC and we're going to move it along the vector 7 comma negative 2. So let's see what that might mean. Now we're not given for this the actual points of ABC, but let's say we make up some points for ABC. Let's say, in fact, let's go back to our graph over here, and let's say that we call this point A, we call this point B, and we call this origin point C. So now we've actually got ourselves a triangle ABC. And let's make ourselves the triangle. Okay, there's our triangle ABC, and according to the notation, we are supposed to translate it along vector 7 comma negative 2. So basically now each of the points, in fact every point on the triangle, but the major points are the vertices, each of these points is going to be translated 7 to the right and 2 down, 7 to the right and 2 down, 7 to the right and 2 down. So basically, we've done this already. When we demonstrated these 3 points being translated 7 to the right and 2 down, we ended up with A prime here, which is the image of point A after the translation, B prime here, which is the image of point B after the translation, and finally C prime over here, which is the image of point C after the translation. So if we go ahead now and create our triangle, A prime, B prime, C prime, we will have the triangle that results from the transformation. Let's join these points to create sides, and let's see our triangle. Okay, so what we've got here is a triangle that was translated in the direction of the vector 7, negative 2. You'll notice that translation is an isometry, that triangle ABC is congruent to triangle A prime, B prime, C prime. They're the same shape, they're the same size, it is a rigid transformation. And one other interesting thing that makes it different from a reflection is that the orientation is preserved. So that, for example, let's take a look at the orientation of the pre-image. A to B, B to C, and C to A, that is a clockwise movement. And similarly, A prime to B, and B prime to C, and C prime back to A prime is also a clockwise movement. So when you do a translation, you preserve the orientation. We went from a clockwise to a clockwise orientation, and that makes it different from a reflection.